Exponential. Exponential function is written like this. We call it exponential function with base b, where b is a base. Base should more than 0 and it cannot be equal to 1, and x is any real number. Before we dive deep, I want you to know what is exponential. Exponential is a mathematical operation written with a to the power of n equal to a multiple with a multiple with a again, and so on. How many a we multiply, it will be equal to n times, or we can call it repeated multiplication. So for fraction we can find exponential function rules. There are 9 rules. You can pause the video if you want to look at one by one, because I will not go deep into each rule. Next, we have the question example here. The instruction said we should find the value of x. Do you know how to solve it, guys? Okay, to solve this question, we should have the same base. You can see now we have different bases. So for the first step, we need to equalize the bases. How? Remember, 9 is equal to 3 to the power of 2, so it will become like this. Now look at the right side. It has the same form with the rule number 3, so we can just multiply 2 with 2x minus 3. Here is the result. Now we have the same basis, so we can process the power directly and then process the functions to find x. From this process, we already found that x is 1/3.
The logarithmic function with base b, where b is bigger than 0 and b does not equals to 1, is defined by log b and is defined by y equals to log bx if and only if b y equals to x. The domain of log b is all positive real numbers and the range is all real numbers. Y equals to log bx means by equals to x. In this sense, a logarithm of a number is an exponent. Log bx is the power to which we must raise b to get x. There are two types of log function. The common log is the logarithm with base 10 and is typically written log x. The natural log is the logarithm with base e and is typically written ln x. Here are examples. For rules of logarithmic, these are the rules we should aware of to solve logarithmic equations. Logarithmic equation is solved by writing both left-hand side and right-hand side of equation in the same basis. Here's an example we can try solving. We've got two logarithms on one side, so we'll combine those. Drop the logarithms and then solve. You can always check for these two possible solutions. In this case, both possible solutions, x equals to 2 and x equals to 5, end up actually being solutions. There is no reason to expect to always have to throw one of the two out as a solution. These are examples of when converting from exponential to logarithmic form. And not to forget, we prepare examples of when converting from logarithmic to exponential form too.
I would like to present about the differentiation under the subtopic minimum and maximum value. How do we know it is maximum or minimum? We can look on the graph, otherwise differentiation can solve it. The graph of a function y equal to fx has a local maximum at the point where the graph changes from increasing to decreasing. At this point, the tangent has zero slope. The graph has a local minimum at the point where the graph changes from decreasing to increasing. Again, at this point, the tangent has zero slope. For example, the equation given is y equal to 5x to the power of 3 plus 2x squared minus 3x. The derivative is 15x squared plus 4x minus 3, which is quadratic with zeros at x equal to minus 3 over 5 and x equal to 1 over 3. Would it be the maximum or the minimum? The second derivative is y double prime x equal to 30x plus 4 at x equal to minus 3 over 5, y double prime x equal to 30 multiplied with minus 3 over 5 plus 4 equal to minus 14. It is less than 0, so minus 3 over 5 is a local maximum, while at x equal to 1 over 3, y double prime x equal to 30 multiplied with 1 over 3 plus 4 equal to 14. It is greater than 0, so 1 over 3 is a local minimum. I inserted a graph for you to look at.
First of all, critical point for a function f of x have only one variable, and there are 3 steps to get critical point. So, step 1, find value of x by f prime x equal to 0. Step 2, critical point equal x and fx. Step 3, determine the minimum or maximum value. We have example here. F of x equal 6x squared minus 24x plus 1. The first step, we make the equation equal to 0. So, f prime x equal 6x squared minus 24x plus 1 is equal to 0. We do the derivative of Lx, so we times 2 to the 6 is equal to 12x minus 24 equal to 0. After that, we move minus 24 to another side and divide 12 to both of them, and then x equal to positive or negative 2. Step 2, we replace positive and negative 2 to the original equation, so we replace positive 2 first. F of x equal 6 times 2 square minus 24 times 2 plus 1 is equal to minus 23. After that, we replace minus 2 to the x. We will have x times minus 2 square minus 24 times minus 2 plus 1 is equal to 73. So our critical point are 2 minus 23 and minus 2 73. Next, critical point for a function f of x and y, its mean have a two variable. So there are 4 steps to get critical point for two variable. Step 1, find the partial differentiation for f of x and y. Step 2, make f of x and y equal to 0. Step 3, find value of x and y by solving the equation. Step 4, critical point is equal x and y. Our example here, f of x equal 2x squared plus y squared minus 2xy plus 5x minus 3y plus 1. So, first step, we do the derivative of an x and y. When we do the derivative of an x, we ignore y. So, we have here 4x minus 2y plus 5, and the derivative of y is equal to 2y minus 2x minus 3. Step 2, we sum the derivative of x and y. Positive x and negative 2x is equal to positive 2x. After that, minus 2y and positive 2y is equal to 0. Positive 5 and minus 3 is equal to positive 2. Okay, and we make it to equal to 0. After that, we move positive 2 to another side and divide 2 for both of them, and x equal to minus 1. Step 3, replace minus 1 to any equation do you have before and make it equal to 0. Okay, I choose this equation, which is 2y minus 2 times minus 1 minus 3 equal to 0, and minus 3 and positive 2 is equal to minus 1. After that, we divide 2 for both of them, and then y is equal 1 over 2. So our critical point are minus 1 and 1 over 2, and this is minimum.
The area under a curve between 2 points is found out by doing a definite integral between the 2 points. To find the area under the curve y equals to fx between x equals to a and x equals to b, integrate y equal to fx between the limits of a and b. This area can be calculated using integration with given limits. Formula to calculate the area under a curve is integral of BA fx dx. We will move on to solve an example. First, determine the area under the curve of integral of e1 to ln x over x. For this particular function, we will need to perform a u substitution. In our case, let u ln x, which will make du equals 1 over x. Now, we will substitute this into our integral to get the following. Then, we integrate using the power rule. Now, plug back in the original variable and then subtract the function values at the bounds.
Still at an integration part, now how to calculate area between two curves. Before we start, I will tell you that I'm not gonna explain about such as what is integration or what are rules of integration or something like that, because now we are talking about the applications of integration. Before we dive into the main question, I will tell you a little bit introduction about how to find the formula. You can see here there are two curves here which symbolized by fx and gx functions, and orange area, it is an area that we want to find. So the question is how to solve it. Let's see the square with a circle hole at the center of the square. Now, how to find the red area of the square? Exactly, the area of a square only needs to be deducted by the area of a circle because the circle is in the square area. Now, with the same analogy, to find the area between two curves, we just need to subtract curve fx area with the gx area where a and b is a lower limit and upper limit. Now, next move to the example. I have two curves here and we should find the area between those two curves. With the same approach, we know the formula here, but still don't know about the lower limit and upper limit. For lower limit, we don't need to calculate because we can the graph. And for upper limit, we can find it by making an equation from both two functions like this. From this process, we can know the upper limit is 1, so the formula will be like this. Now, we just proceed it and we find the result of the area between two curves is 1/3. Thank you for watching our video.